Folks, I want to talk about the essence of homeostasis. Homeostasis is a very biological, important component of living systems. It's, of course, a hallmark characteristics of all living systems on planet Earth. So it's a pretty nice definition, which I liked. Homeostasis is a property of a human biological system where the self-regulating process tends to maintain the balance for survival. The regulation takes place in a defined internal environment. For example, the presence of glucose in blood plasma, regulation of body temperature, extracellular fluids of an animal, despite changes what the animal has eaten or what it had or what it is doing. Every variable is controlled by homeostasis together to maintain life. So homeostasis, I mean, it's talking about in terms of like animals and so on and so forth, but homeostasis actually, I mean, gosh, I mean, every living system that you can think of, plants down to paramecium, bacterial organisms, on some level or another, they all actually have to display some level of homeostasis in order to survive. So every time as I teach my students homeostasis, always think of the term balance, balance, balance. Homeostasis simply just means balance, regulation and balance. So this is just kind of like just a little graph, just showing how you have the control of the effector and the receptor. So basically, just kind of think about, let's see here, let me get the pen here. Okay, so just think about, again, balance. Homeostasis, kind of like a seesaw, teeter-totter balance. You can have too much of something, and we'll talk about examples of that, and that's out of balance. Or you can have too little of something, and that's out of balance. So again, homeostasis is just talking about balance, okay? And like I said, pretty much every organism on the face of the earth has to display some level of homeostasis in order to survive. So these are components there, right? You know, so you have the stimulus, the sensor, the control, and the effector. And then once that effector, something happens, you get like a feedback regulation or feedback loop to try to alter or change things so that you just maintain basically the survival of the organism. So using this as a specific example on the right. All right, so we know that our body temperature actually is about 37 degrees Celsius. Obviously, Celsius is part of the metric system. So for our standard unit of measurement here in the United States, it's 98.6 degrees Fahrenheit, which is normal body temperature. Well, basically what happens is that if you have it exceeding 37, then you're getting a little bit too hot. Maybe you're outside or something like that, right? During this hot summer day. The nerve cells on the skin senses the heat. Okay, the control temperature regulatory center in the brain is like, okay, we're getting too hot. We're getting too hot. We don't want to get too hot. And then that might be like a thing where they, hey, you know, you have your sweat glands opening up. What happens is that's going to release sweat onto your skin, and then what's actually happens is that you want the water to evaporate from your skin, and therefore just trying to an attempt to cool off the body. I saw this. I thought this was kind of interesting. Here we have Homer Simpson, and again, a homeostasis scenario here. So again, sensor, okay? So here's response, all right? Basically, oops, you know, maybe I probably should start here, okay? So the stimulus, high temperature, very high temperature, all right? It's signaling that to the brain, sensor. The response is going to be, hey, you know, sweating, okay? To release water so that the water evaporates, all right, and therefore hopefully cooled off the body. Or on the other hand, say if the temperature is too low, too cold, sensor, boom, and guess what Homer is doing? He is shaking, he is shivering. The purpose of shivering is actually to move our muscles around, contract our muscles to generate heat for our body, to help generate heat for our body. So that is why we shiver when we are cold. Here's another thing in terms of blood glucose, diabetes, and so on and so forth. So again, we're trying to get balance. We're trying to achieve on some level or another, okay, normal blood glucose levels. All right. So here's a situation where the blood glucose level is just simply too low. So we need more glucose into the circulatory system. So it sends a message or anything to the pancreas. Pancreas, in a sense, sends a message to the liver. The liver basically will break down what we call glycogen into the free-floating glucose molecules to get the glucose molecules back into the circulatory system where there was too little up here. And now, again, we wanted to actually achieve normal blood glucose levels. All right, so that is basically when a person has too low glucose. And that's a scenario that's called hypoglycemia. Whereas over here, too much glucose. Of course, we associate this with diabetes. Too much glucose floating around in the circulatory system. That's why when people take the glucose monitor test, and it's just the glucose levels are just too high. So sending a message to the pancreas. The pancreas is going to secrete insulin. Insulin simply serves as the keys, if you will, to open up the doors of the cells so that the glucose can actually leave the circulation to get inside the cells. All right, and then lowering glucose levels there. So again, we can achieve normal glucose levels there in our circulatory system. And again, excuse me, I'm trying to clear my throat. This is like around approximate normal levels, okay, of basically, maybe from maybe 70 on up to 110 of our glucose levels. All right, it says here normal fasting levels. Fasting is basically, of course, if you hadn't eaten. So basically, this is where our body wants to be, somewhere around the normal level. I know with different patients and everything, their natural normal level might be a little bit higher or normal. But if it's too high, we call that hyperglycemia. If it's too low, we call that hypoglycemia. So again, going back to the whole issue of homeostasis, again, we want balance in this area, in this region. And again, if we have too high or too low, again, the previous slide, as I explained, is your body's way to try to compensate to return the blood glucose levels back to normal. This is an interesting graph. Actually, I like this graph. Again, it's just showing in terms of blood glucose and blood glucose or blood sugar and blood insulin. Again, insulin is the hormone that opens up the cells for the intake of glucose. So I kind of got distracted, got a little beep here. So you have breakfast. So what happens here at breakfast, okay, basically with the black line, it goes up. Okay, your glucose levels goes up. Why? Now breakfast originally, you know what breakfast means? It means break fast. Actually, that's the original term, break fast. Why? Because you're fasting, of course, while you were asleep. So we pronounce it breakfast, but it's actually break fast. We're breaking our fast. We're eating. We're fasting during the night, and now we're eating, so we're breaking our fast. So then you have the blood. So now you have the blood insulin. Actually, is going up, corresponding, following the glucose levels. And then everything kind of returns back to basal levels, and then you eat again at lunch. Glucose level is going to go up first. Insulin level is going to go up to compensate that, to bring more of that glucose into the cells, and so on and so forth. And then you see the same thing for dinner. And then now after dinner, evening, we're going into the fasting area. Okay, overnight we're going into fasting because we're not eating, because we're sleeping. And then again, the next morning, we're going to break our fast. or in other words, breakfast. Thank you.